Graham's law. This is the formula for Graham's law, and I will derive that for you later. But for now, let me explain to you what it is. Graham's law relates the speed of a substance to its mass. So what that means is if a molecule is small, it's very light, it will be very fast. And if it's heavy, then it will be very slow. Okay? So as the mass, the molar mass goes down, it gets lighter, the velocity goes up. So what kind of relationship is that? That's correct. It is an inverse relationship. As it gets heavy, the mass is high, the molar mass is high, and it will be slow. The velocity is slow. Okay? So the speed of the molecules is, as they either effuse or diffuse, is governed by Graham's law. So you're going to be hearing me say effusion or diffusion. So the difference between them is effusion is when it exits. Do you see this exiting through a hole, the gas molecule exiting? That's effusion. And the way I remember it is E for exit, and diffusion is just random mixing of one gas and another, not coming out of a hole. So an example would be, let's say if you fart coming out of a hole, that would be effusion as it exits. And as the gas goes through the room and somebody else smells it, that would be diffusion, random mixing with other gas molecules. Okay, so the speed of the molecules, of course, is related to kinetic energy. Okay, the formula for kinetic energy is equal to 1/2 mv squared, where m is the mass and v is the velocity. Okay, so what happens here, as it gets hotter in the room, as temperature goes up, the kinetic energy also goes up. So those two are directly related. Okay, so let's go ahead and look at two different atoms. You have a neon and a helium atom. So in a container, they're in the same container, which means they have the same temperature. So let's say it's I don't know, 23 degrees Celsius. That's about room temperature. Okay. Neon is huge, really heavy, and helium is very light, small. And if you don't remember, look at the periodic table. Where's my periodic table? Over here. Neon weighs 20 grams per mole, helium weighs 4. So it's very light, not very dense. That's why they put it in balloons, right? Okay, where is it? So if they're in the same container, that means they're experiencing the same kinetic energy. So kinetic energy is the same. But what's really weird is even though the kinetic energy is the same, the neon will move slowly and helium will move faster because it's lighter. Okay, so the answers up here. Neon will move slow because it is heavy. Okay, remember Graham's law states that as the mass goes up, it's heavy, the velocity goes down. Okay. What can you say about their average kinetic energy? Well, the kinetic energy of neon and helium are the same. The kinetic energy of helium is the same as the kinetic energy of neon, because they're in the same container. Okay, so you might wonder, well, why are they moving different speeds? Because if kinetic energy here is constant, because they're in the same container, is equal to 1/2 mv squared. Okay, as given up here in the formula for kinetic energy, which means if your mass goes up, then the velocity has to go down to make it equal the same kinetic energy. See that? So even though they're in the same container, same temp, one can be going faster than the other because of their mass. So let's go ahead and look at this distribution. This is called Boltzmann Distribution, and I showed this to you in the previous video. On the y-axis is the number of molecules. The x-axis is this. This is the velocity. This is the root mean square speed, but for our purposes, we'll just call it its speed or velocity. So at 273, it's cold. At 2,273 Kelvin, it is hot. As you can see, the velocity is slow over here, about 500 meters per second, and the hot is about 1,500 meters per second. So the cold molecules are slow, and the hot molecules are fast. That's what the graph tells you, okay? Now this graph is a little bit different. Here the temperature is constant. Pretend all these gas molecules is in the same container, constant. That's a C. Okay, so here's oxygen. The mass is in parentheses is 32 grams per mole, 16 plus 16, it's O2. And this is hydrogen gas, mass of 2 grams per mole, one each. 1 gram per mole each. What can you say about oxygen? Oxygen is very heavy, therefore it is very slow. Here, hydrogen is very light. That's why its speed is very high. And even though they're in the same container, as one goes up, the other has to go down. As mass goes up, the velocity has to go down. Okay, in the next video, I will derive Graham's law for you. But first, you will be watching a video on an experiment and how we can prove Graham's law.